Hey, hi everyone. My name is Varsha and welcome to Study with Varsha. So today we are going to discuss a very important topic that is Helm. So if you are a DevOps engineer or a developer, you must be heard this term as Helm. So today we will discuss what is Helm and all. But there will be a question on your mind. It may be possible that, ma'am, why you started with Helm? Why you didn't start with Docker, Kubernetes, and then Helm? So the reason is that first I want to give you an overview about Helm. After that, I will start teaching Docker and Kubernetes, and then I will take a session on Helm. So that will be the final session. Today is the intro kind of thing about the Helm, so you will understand what is the difference between both the thing, and it will be easy for you to understand about Helm because that is very important for us. So if you will see this PDF, here it is, one developer is there, okay, and some he is building the code. It is going with the Helm chart, templates will be there. After that, it will be hosted in the repository, then chats will be there, and find and downloads. Inside that, there will be something like downloaded, what users, this is admin, it will install with the help of Helm. What is workstation, so scheduler will be there, API server, the controller, etc. So this is the architecture of the master node, okay. After that, Kubernetes cluster that releases will be there, and it will be separated in the one node 2, node 3. This is about a simple overview what it is saying. Now if you'll come to the down, here Helm chat is there. So inside Helm chat, Nginx chat, like chat.yaml file is there, chats is there, templates is there, config map.yaml, deployment.yaml, service.yaml, and values.yaml. So if we'll talk in a short, so all the YAML file is there inside a Helm chat. So we can see the bundle of YAML file is present inside a Helm chart. That is not wrong. Okay, now dev values.yaml, that is in the dev environment. Staging environment, stage value.yaml is there. Production environment, prod values.yaml will be there. So combined to that, all the YAML file we can put together in a Helm chart. Okay, now there here if you'll see this simplified deployment, that is packaging, so bundle of complex app into a single app package. So when we are handling a large project, so lots of complex apps will be there, so lots of YAML files will be there. So how can we will manage? For example, so to handle this, so all these bundles, if we will do with the help of Helm chart, so it will be very easy for us. We just have to write one command, that is helm install my app. So all the things will be installed for you. So this is for packing and packaging an application. This helps us a lot. Now for example, if easy version control and recovery you need, so application lifecycle management, first we have to install, upgrade, roll back. So all thing we can do with the single one command, like help install, helm upgrade, helm rollback. Now we all know to deal with microservices, it's very complex, and deploys independent service together, it's very hectic. But with the help of Helm, it's very easy. Now environment consistency, like dev, stage, and prod. So if we have a YAML file, that will be replaceable, like, or we can say replicable deployment across environments, so it will be very easy for us. Now the last but not the least, Helm, if we will create in a dev, then that will create a Helm chart. Now we can upload it to the repository, any repository. Now after it, you can download the chart, and then Helm user, with the help of that, we can deploy it to the Kubernetes, and your application is ready. So this is the thing which we are going to study today. So before that, first we understand what is Helm, introduction to Helm. I am going to cover all this thing, but let me ask you one thing. Do you know about Linux? If yes, so you know about some package manager, correct? For example, if you are using uh, Ubuntu Linux operating system, then we are using package manager as apt. For example, if you are using Red Hat, then you are using package manager as yum. Why? What is that apt yum? That is the package manager. So what it will do? For example, if apt yum some package manager you are not using, if you have to install Docker or anything or Java in your application, so what you have to do, you for example you have to install Jenkins. So what we previously used to do, we used to go to a site that is, let me show you, we have to go to here, dlcdn.apache.org. Okay, you have to go here, and again you have to click on it, then you have to install it, then you have to unpackaging it, and then you have to set the path. So lots of manual work was there. So to over and see, if you can say okay, for that we can write the scripts, it's okay. If you'll write a script to install Java, for example, after 2 months that Java version is not supporting, again you have to rewrite all this file, and it will take a lots of manual effort. For example, if you have to install Docker anything, you will go to the official website, download, then untar it, and then fix the path. Okay, so but after some time, suppose that Docker itself not supporting it, it is not supporting itself, then what you will do? Again you have to uninstall it. So you know what this thing is doing? It is creating a lot of manual efforts, and it is wasting a lot of time. So how can we avoid it, and how can we do in a better way, so that after every 2 months or after every 3 months we should not have to look into that? So yes, there is a possibilities, and there is the things which can we can fix it. So later apt came in the market, that package manager or yum came. So what it will do? It will do in a single command, apt install python 3. It will install the Python with along with all the dependencies, and it will set the path. So you no need to do all the manual yuck. If you have to install Docker, okay, apt install Docker. So what it is doing? It is doing this thing in a very easy way. So how Helm came in the market? It is more or less related to like package manager itself. So we can compare. So Helm, it is doing the like package manager apt, and Ubuntu is making our life easy to installing all the things. In the same way, Helm will work for Kubernetes. So if any user is there which is there inside our application or not, or inside any or in the world anywhere, they can install all the packages, and they can manage all the YAML things by with the help of Helm. So that's why it is very useful if you are using Kubernetes. So without any further delay, let's start. So we have to understand what is Helm. So Helm is an open source package manager for Kubernetes. I told you why it is open source, and it is free of cost, anyone can use, and package manager same like apt and yum, that helps developer and DevOps engineer to define, install, upgrade, manage Kubernetes application, that we already discussed. So in Kubernetes, deploying an application usually require many YAML configuration files. Yes, that is a fact, because we used to define deployment.yaml, service.yaml, configmap.yaml, secrets, ingress, horizontal pod autoscaler. Too many YAML files is there. So without Helm, it's really very difficult to manage all of this thing. So managing these files manually become difficult when application grow larger. So Helm will solve this problem by packing all the Kubernetes resources into one single deployable unit that we call as a Helm chart. So Helm simplifies the entire life cycle of an application deployed on Kubernetes, including installation, configuration management, upgrade, and rollback. Now, the next question which came in our mind: Why Helm is needed? Because see, you can ask, okay, package manager is there and too many things is there. Now why Helm is needed? So before Helm existed, Kubernetes deployment were managed using raw YAML files. Okay, so raw YAML files, if you are managing, there are lots of problem was there. So what was the problem? Let us discuss one by one. First thing is that larger number of YAML files was there. Just a second, friends. Yeah. Yes, yes. So I'm going to discuss that problem with the traditional Kubernetes deployment. So there was a large number of YAML files just now I have shown. So what was the problem? That difficulty was there in the configuration management, because it, if you have to manage multiple environments like dev, prod, pre-prod, so it was very difficult, and it is also hard to reuse deployment configuration. So complex upgrade and rollback process was there, no proper versioning of deployments was there. So deployment.yaml, service.yaml, all this fits. So managing all these manually, but it was time consuming. So what and it may be a chances of mistake also. So Helm addresses these challenges by providing application packaging, templating, version control, and simplified deployment commands. Now we understand it, what is Helm, why we need Helm. Now the third thing came in our mind, okay Varsha, every time you are discussing about Helm chart, what do you mean by Helm chart? So Helm chart is nothing but it is a packaged collection of Kubernetes resource definition that describes how an application should be deployed in a Kubernetes. It means all the YAML file is there. So bundle of YAML files we can say as a Helm chart that will contain metadata about the application, default configuration values, Kubernetes resource templates. So an application like Nginx or MySQL can packaged as an Helm chart, allowing users to deploy it with a single command. So charts are reusable and can be shared through a chart repository. Okay. Now, okay. So now Helm chart structure. So a typical Helm chart has a structure directly layout. For example, my chart is there, chart.yaml is there, values.yaml is there, templates is there, deployment YAML is there. So each file has a specific purpose. So okay, so you want me to explain all the charts? It's not possible, but yeah, I'll try to cover. Oh, okay, okay. So chart.yaml. First, you understand what is chart.yaml. Okay, so this file contains metadata about the chart such as chat name, version, description, application version. Like if you are going to write a service.yaml file or deployment.yaml file, so API version, kind, metadata, and all this thing is there. In the same way, here charts will work. So inside the chart, you can read the chart name, version, which version you are using, description, and application version. That like name, version, description, API version. Now values.yaml we will discuss. I'm explaining these two later. If you want, we'll discuss later, or we can you can and for the online guys, which whoever is seeing this video in the YouTube, they can just comment it, or they can directly ask this question in my Telegram channel. I'll answer it. As of now, I'm explaining two. Now values.yaml. So this file contains the default configuration values of for the chart. For example, number of replicas, container image, service type, port number. So users can override this value during installation. So because of that, we are using chart.yaml and values.yaml. Now templates directory. So this folder contains Kubernetes YAML file that defines the resource to be created. These files use templating so that configuration values can be dynamically inserted. Yes. Now, Helm templating concept we will try to understand. So, what is Helm templating concept? It is templating is based on engine, and that is on the Go templates. So templating allow developers to create dynamic Kubernetes manifest. You all know manifest file. Inside the manifest file only service.yaml and deployment.yaml file will be there. Yeah, so that Helm allow. So instead of writing YAML files here, what it will do, it is Helm templating, that it will variables can be used. For example, replica count can be defined using a variable instead of hard coding it. And during deployment, Helm replicas variable with actual value from the files will be default. And this approach allow the same chart to reused across multiple environment, like this file only, like in case of manifest we have to write multiple times, but with the help of Helm we can write use same Helm with development, staging and production. So that's how it will help. Now, Helm releases will be there. So, what is Helm release? So, a release is an instance of a Helm chart running in a Kubernetes cluster, that we understand. Now, when a chart is installed, Helm creates a release. For example, chart will be blueprint of the application. So, release will be running instance of that chart. Okay, so multiple areas releases can be created from the same chart. For example, Nginx tab, Nginx stays, Nginx prod. So each release can have different configuration. Now, Helm architecture. So Helm architecture changed significantly between Helm v2 and Helm v3. So Helm versions 2 architecture. Helm v2 uses a component called Tillers. Component include Helm client, Tiller server, Kubernetes API server. So Tiller can run inside the Kubernetes cluster and manage deployments. However, this design had security risk because Tiller require high privileges. Yes. Helm version 3 architecture. So Helm 3 removed Tiller completely, and now new in the new architecture Helm CLI communicates directly with the Kubernetes API server, and this improves security and simplifies architecture. So released information is now stored inside Kubernetes secrets, not directly. Yeah. Now Helm repository. So Helm charts are distributed through Helm repository. We understand Helm chart. Now Helm repository. So whatever the charts are there, that will distributed with the help of repository itself, which is similar as a software repository. For example, Bitanami Helm chart. That is very important Helm chart, and when I will show you the practical, I will show how can we will install and add to our Helm chart. So Bitanami, that name you just remember, and Prometheus community chat, Grafana chats. So these repository host charts for commonly used applications. So user can search and install charts directly from repository like MySQL, Redis, Nginx, Prometheus, and Grafana. Helm application lifecycle. First, we have to install it. Helm install the application using a chat. Configuration, upgrade, rollback, and uninstall. So these are some life cycle. So if anyone is asked in the interview, you can say that okay, installation is there, configuration is there, upgrade is there, rollback is there, and uninstall is there. Now, Helm in DevOps and CI/CD. Why we need Helm and what is the importance for of Helm for the developers? Because Helms play an important role in the DevOps automation pipeline. So in the modern days, developers process the code, CI pipeline builds the Docker image is now posted to the Docker container registry. Helm chart upgrade that image also, and help deploy upgraded application to the Kubernetes. No need to manual intervention. So Helm allow teams to automate Kubernetes deployment in a tool such as GitLab, Jenkins, GitHub, Argo CD. Now, advantage of Helm. So, most important is it is simplified deployment. We can reuse it for multiple environments. Configuration management is very easy. Version control will track the applications. Rollback is there, and integration is very easy. So you can say in a simple word. Now, so where really in the real world we can use. So in large organization, application may consist of many services such as backend, front-end, database monitoring tools. So instead of manually deploying each component, team package everything into the Helm chart, deploying a monitoring stack. So that is some real cases. If you want to take a screenshot, you can take a screenshot. That will help. I'm not going to repeat it. Yeah. Now, last thing, Helm versus Kubernetes YAML. Why Helm and what the pros and cons without Helm? So, without Helm, manual configuration is there, repeated YAML files will be there, and difficulties to environment management. With Helm, parameterized templates is there, and we can reuse charts, version deployments, and automated upgrades and rollback is there. Now, so in the summary, we can say Helm is a very powerful tool that simplifies Kubernetes application deployment and managements. By using Helm chart, organization may standardize deployment, reduce operational complexity, and automate application lifecycle management. So Helm is widely used in the modern DevOps practices and is considered as an essential tool for managing application in Kubernetes environments. So that's it for today. So hope you like the video, and if you guys have any question you can ask, so offline also, means in the chat also. Thank you for watching Study with Varsha. Have a great day. Okay.